Hi and welcome to this Leaving Cert Higher Level Maths revision video. In this video we're going to look at some number systems revision and in particular focus on our irrational numbers. A lot of this revision is focusing on what we would have looked at junior cert, but it's good to have a basis of this even though it doesn't appear in the Leaving Cert as exam questions. So let's look at our number systems. So we have our natural numbers, which are our counting numbers, our integers, which are basically our positive and negative whole numbers and also include 0. We then have our rational numbers. So rational are any numbers that can be written as a fraction. So you don't necessarily have to have them as a fraction because all of our integers and natural numbers can be written as fractions over 1. And then our real numbers. So our real numbers are all of the numbers on the number line. And if you have already looked at complex numbers, you'll know that there is more than just the real numbers. So our systems all have letters. So natural numbers have an N, which makes sense. Integers Z, which is German for numbers, so Zahl for number or Zahlen. Rational, which is Q. That Q comes from the word quotient, which is another word for division. Rational is all about division. And then the real numbers has OR. So the real numbers can be split into two distinct sections. The first are rational numbers and the second are irrational numbers. And as you might guess by their names, they are the opposites of each other. So a number is either rational or irrational. It cannot be both. So when we're talking about rational numbers, they are, like I said, every number that can be written as a fraction. And we have decimals that fall into this because if you think of a half, it can be written as 0.5, so that is a rational number. So with decimals, it becomes a little bit trickier. So how do you know by looking at a decimal that maybe isn't familiar whether it is rational or not? And any decimals which recur, so your recurring dots, so think of your third can be written as 0.3 recurring, or terminates or end, they will all be rational numbers. So if you have a decimal that ends, it can be written as a fraction. Irrational numbers then are ones that cannot be written as a fraction, and we have really important ones, and the important ones to know are pi, so 3.14159 on, square roots or any roots, so cubed roots and so on, so our surds, and also E, Euler's number, which we investigate and work with a huge amount when we get into functions. So let's look at a quick example here. So which of the following is not a rational number? So they're basically asking us for the irrational one. And there is only one, and the answer is pi. Now this is a nice question. Seems very basic, but it opens up some, I suppose, really good questions for us. Because if you look, these two are the same. So the first one mightn't have been too familiar for you, but these two are the same. And then actually what we're seeing is 22/7 may be familiar because it's often used as an approximation for pi. And 3.142, so it's 14159, So pi, this is again another approximation for pi. So sometimes we see 22/7, you might think that's pi, and pi is irrational, so this must be irrational. And that's not the case, because 22/7 is a rational approximation for pi. It can be written as a fraction, as we can see. So here, it can be written as a fraction, because it's 3 1/7. Okay, 22/7, clearly a fraction. Now here I have a decimal, but the decimal terminates, it ends, which means it cannot be irrational, it is irrational. So here I have pi. So pi is a non-repeating or non-recurring if you prefer, non-terminating, so it never repeats and it never ends. non-terminating decimal. Okay, so if we were to write it as a decimal, it'd be non-repeating, non-terminating. So here are some of the most famous irrational numbers. So pi, Euler's number, and then square roots, cube roots, and so on. So they're the three main types that we meet on our Leaving Cert course. E is probably the one we meet the most. We don't really meet it in terms of it being irrational a lot, but that should always be in the back of our mind that that is an irrational number. So let's look at a Venn diagram here. So we have a series of numbers and we have to place them in the correct spot. So we have 5, we have 1 plus the square root of 2, we have minus 9.64039115 ... That ... means it's continuing on. There's no recurring dot on top of any of the numbers, so we're assuming then that it will continue in some kind of way. We have minus a half, we have 6.36 recurring, we have 2 pi, we have minus 3, we have cubed root of 8, we have 0, and we have minus root 3. And there is one there that is a bit of a red herring, so just be careful. And that is the cubed root of 8 can actually be simplified to 2. So just be careful. So putting them into the right places should look something like this. Okay, so 5, it is a natural number. It goes in here. 1 plus root 2 is not natural, not integer, not rational, so it must go out here because it is still on the number line. So it sits in the real bubble but not in rational. This minus 9.64039115, that goes on forever. It is non-terminating, non-repeating, so it is irrational. Minus a half is a rational number, that's fine, so that's in Q. 6.36 recurring. It is rational because it is a repeating decimal, even though it doesn't terminate. 2 pi, so pi itself is irrational. So if I do anything at all to pi, it is still irrational. So it sits in our big or circle, but not in Q. Cubed root of 8, that was the tricky one. It is 2, so it sits in our natural numbers. 0 is an integer, so it sits in Z. And I think I missed my minus 3 at some points. That's an integer as well. And minus square root of 3 sits out in our real bubble, but not in our rational bubble. So then this section here that's highlighted in yellow, this section is where we place the irrational numbers. So at the start, when we worked through all the letters, I gave you the 4 letters that we have on the screen there, but I didn't tell you what we have for irrational. And that's because irrational numbers, the set of irrational numbers, it doesn't have its own letter. It's actually a combination of letters that are already here. So really that yellow piece are all the numbers in the real bubble but are not part of the rational set. And how we write that is or less q. So this is sets notation. It's called the set difference. That's like a subtraction. So imagine you have all the real numbers, but you take away all the rational ones. So what would you be left with? And the answer is irrational. So the symbol, or how we write irrational numbers, it's not one single letter. It is or less q. So our final example here for number systems is we are given 5 numbers and we're being asked to categorize the n, the z, the q, or less q, and or. So for each of these, n being natural, z being integer, q being rational, or less q being irrational, and or being real, we need to figure out whether it's yes or no for each of those. Now, before we do anything, what I'm going to do is bring your attention to these 2 columns, because what this is, it's an either or. Okay, so it's either or. It's either going to be rational or irrational. Now, because of where we're at, this video is not looking at complex numbers, okay? So I'm doing this from kind of just an irrational point of view. So then every number here is real. So I'm going to fill in my real bit first. So yes, every number couldn't be written on the number line. So then I need to figure out if it's rational or irrational. So root 5 is irrational, so can't be rational. 8 is rational, so cannot be irrational. -4 is rational, so not irrational. 3.5 can be written as a fraction, so it's rational. Now, this one causes problems, and this is why I put this question in, because it opens a good discussion. So a lot of times students say, well, surely that's rational because rational numbers can be written as a fraction, and this is a fraction. But it's not a true fraction because that pi is irrational. So because there is a pi there at all, it makes the whole number irrational regardless of how it is written. So yes, it is irrational because of the pi. It doesn't matter that it's written in terms of a fraction. The fact that there is a pi there at all. And the same will be true for a square root or e. Doesn't matter how it's written. Once any of those three things are there, so pi, e, or a third, we're going to have an irrational number. So then we just need to look at n and z. So is it a natural number? Is it an integer? Well, anything that is not rational, it cannot be natural. It cannot be integer either. For these ones, we have to be a bit more careful. So 8 is a natural number, so it is also an integer. -4, no, it's not natural because it's minus, but it is an integer. And 3.5, there, it is not a whole number, so it is neither natural nor integer. So that's just a bit of deep thinking, but again, these are all just junior cert questions, really getting us back thinking about irrational numbers and how they fit in. We have never really seen these kind of questions asked on the Leaving Cert. They're more going to be embedded in questions than asked explicitly.